to have you back, BC Calc students. All righty. I made a bunch of mistakes, or a couple mistakes on that last video, so I'm probably going to do these in little pieces, only because I anticipate I'm going to make mistakes. Teaching in a live classroom with real students is remarkable. It's much harder to do this from home because there's no one there to catch mistakes and raise hands and say, hey, I think you missed a minus sign here and there. So I don't want to say I'm getting self-conscious about it, but I don't feel good making videos where there's a mistake in the middle. And if you're trying really hard to understand, you don't know that that's a mistake until later. And so anyhow, I'm of course doing my best, and I'm only human, and I miss you guys, and I wish that you guys could be in the classroom with me right now. Okay. All right. The function f is defined on the interval here, and it says right here, graph of f. It's defined in the integral, the closed interval from -5 to 5. The graph consists of 3 line segments and is shown in the graph below. So here are our 3 line segments, and we define g as the integral of this function where we start integrating at -2. What's really important in this problem is that this is a constant. Later on, that won't be true. Later on in this course, in a few days, that won't be true anymore, and it's going to make things a little different, okay? And something else to notice is that these match, okay? And under those circumstances, if this is just a constant and these match, then we can say that that if g of x is the integral of f, then g prime of x must equal f of x. The derivative, g is the integral of f of x, so the derivative of that must just be the original function. Or we could say g prime of t is just f of t. And so that's helpful to know, okay? That'll cut a lot of time out of analyzing doing these problems in this lesson, okay? Knowing that this must be the case, okay? So first question says find g of 2. And you guys, people get kind of intimidated by that. Just copy this down. Use the literal definition of what this is asking for. By definition that they gave us, g of 2 must equal the integral from -2 to 2 of f of t dt. Okay. Now that I've done this, I could change this to f of x dx if I wanted to, because this is no longer a variable at this point. But let's look at the meaning of this. G of 2 is asking us to determine the area under the curve going from -2 to 2. So basically what that is asking us to do is to calculate that area right there. Okay. And so the area of a triangle is just 1/2 of the base, 0, 1, 2, 3, 4 times the height, 1, 2. And so we end up with 4. And there we have it. Okay. All right. The next one, g prime of 2. Well, we fortunately wrote this down earlier. Given that these match, that this upper bound matches that, and that the lower bound's a constant, and this is just the function here, we absolutely can simply declare that it must be true that the derivative of g is just equal to that original function f. And so g prime of x equals f of x. And so g prime of 2 must equal, that was like a 5. G prime of 2 equals f of 2. So we simply need to look at this function f, and there it is. It tells us f of 2 is equal to 2. Okay, and there we have it. Okay. All right, I'm going to stop there only because I'm worried I might make a mistake on the next video, and I don't want to have to reshoot this video. Okay. All right, I'll catch you at the next video.